So, this is the schematic diagram of the system. I have the RMS value of line to line voltage of the AC bus on the rectifier side as ER, and I have the turns ratio including the off nominal tap TR N1R is to N2R, and the RMS value of the line to line voltage of the AC system bus on the inverter side is EI, and this is N2I is to N1I divide N1I Ti. So, the voltage at the DC bus on the rectifier side is VDR, the current is ID, and the voltage at the DC bus on the inverter side is VDI. Now, we got some equations. EDR is a not, before that I will not introduce a few things. EVR is N2R by TR N1R into ER. Similarly, EVI, the valve side voltage is equal to N2I divided by TI N1I into EI. So, we derived some relations. VDR can be written as EDR minus, did you derive this? Okay. We related VDR, EDR, ID and RCR minus RCR, ID. Then we also derived the relationship between VDI, ID, EDI minus RCI, ID. Okay. So, if we try to draw an equivalent circuit corresponding to these two equations, the last two equations, I have a voltage source in series with a resistance. The voltage source is EDR, the resistance is RCR, and the current is ID. Similarly, if I take the second equation and I call this voltage as EDI, suppose the voltage here is VDR and the voltage here is VDI, and the same current ID flows here also, and corresponding to the line, the transmission line, suppose there is a resistance. So, let me call this resistance as RD. Okay. So, if I have to satisfy the second equation, what should be the resistance here? Minus RCA. Okay. So, if I have to, please note this RCR and RCI are not actually physical resistances. There is no loss corresponding to RCR and RCI. Please note that they are due to leakage inductances. If you look at the expression for RCR and RCI, it is in terms of the leakage inductance or leakage reactance. So, there is no loss corresponding to these two. So, one should not assume that there is a loss due to RCR and there is a generation due to minus RCI. Okay. So, the only loss is due to RD. RD is the physical resistance. It is the resistance of the transmission line. So, we got an expression for EDR. What is EDR? Do you recall EDR? 3 to root 2 by pi NB N2R by N1R ER by TR cos alpha R. Is this okay? Did we derive this or not? So I don't want to again go back to the ones which I have already derived. So have we derived this equation? Yeah. Okay. Similarly, if I look at EDI, no. No means, I mean, maybe I would have, I have written in terms of EVR, that's all. So substitute the expression for EVR. EVR is N2R by TR N1R into ER, that's all. So now I am writing in terms of ER. Instead of EVR, I am writing in terms of ER. Similarly, EDI is 3 root 2 by pi NB N2I by N1I EI divided by Ti cos gamma I. Now, if you look at this expression for EDR or EDI, you will note that 3 root 2 by pi is a constant, NB is a constant, N2R, N1R are constants. Okay. Similarly, in the expression for EDI, 3 root 2 by pi NB, N2I, N1I, they are all constants. So, I define a constant AR, A is just a constant, R subscript R means for rectifier, as 3 root 2 by pi NB N2R by N1R. So, please note I put all the constants as one factor AR, that's all. Then define one more constant AI. A is a constant, I subscript I stands for inverter. 3 root 2 by pi NB N2I by N1I. So, if I make these two definitions, then if you look at the expression for EDR, EDR is AR into ER divided by TR cos alpha R, and EDI is equal to AI EI TI cos gamma I. Now, please note ER is not a constant. ER is dependent on the AC system on the rectifier side. So, the voltage available on the AC system may change with time. Okay. So, maybe at one point in time it has some RMS value for the line voltage. After a few hours it may change, though by a small value. So, it is around nominal value, but it may slightly change. So, it is not a constant. ER is not a constant. Similarly, EI is also not a constant. So, that is why I am not including that in the definition of AR or AI. Okay. Now, come back to this circuit, this equivalent DC circuit. So, if you look at the current in the circuit, ID can be written as the difference between the two voltages of the sources, EDR and EDI, divided by the effective resistance, RCR plus RD minus RCI. Okay. So, I can write ID as, okay. So, in place of EDR, I will just straight away write the expression for EDR. Just now I got the expression for EDR, AR ER by TR cos alpha R minus EDI is AI EI by TI cos gamma I divided by the effective resistance is RCR plus RD minus RCI. Now, RCR and RCI will slightly depend on tap, okay. But if I ignore that variation in RCR and RCI due to the change in the tap position, then the only variables that are there in the expression for ID are, so if for the time being, if I ignore the variations in RCR and RCI, RCR and RCI are constants, RD is anyhow a constant, AR is a constant, AI is a constant. So, ER and EI are something which depends on the AC system on the rectifier side and the inverter side. Then TR is a control variable, it is a tap. So, the user can decide the value of TR, the tap position, on load tap. Similarly, the on-load tap on the inverter side, Ti is also a variable. And there is another variable, alpha r, the user can control alpha r. And gamma I is another variable which the user can control. So essentially, there are 4 control variables. Now, please note, there are two more variables, ER and EI, but they can't be controlled. They depend on the system, the AC system on the inverter side and the rectifier side. But what can be controlled by the user are TR, TI, alpha R and gamma I. So, 4 control variables. So, the 4 control variables are TR, TI, alpha R, gamma I. Now, if you look at TR and TI, they are the control variables due to the tap. So, if there are mechanical switches based tap, then these are slow compared to alpha R and gamma I. Now, you know that one can use a mechanical switch or a thyristor based switch. So, if you look at the power converter, the electronic switches are thyristors which are very fast. See, hope you would have noticed that there is a large difference between a mechanical switch and a power electronic switch. Mechanical switches are slow in operation. See, it may take a few seconds or at least a fraction of a second maybe, but to initiate the movement from on position to off position or off position to on position. But if you look at thyristor, how many times in a second it switches on and switches off? Take the converter, 6 pulse line commutated converter, take any thyristor, 50 times. It is now, if you look at, there are many other faster switches in fact. So, the slow switch that we are considering here, the slow power electronic switch itself is switching on and switching off 50 times. You can't think about such a frequency of switching for mechanical switches. Imagine switching on and switching off this switch for 50 times in a second. You can't do that. Not just mechanically, you use some automation to do it. You still can't do. Okay, there are limitations in the frequency, and there are many other limitations, of course. But the main point here is it is not fast. Okay, it takes some time to initiate, and it is not as fast as the power electronic switches. So, essentially, among the 4 control variables, 2 control variables are slow. So, it takes time to change the 2 control variables TR and TI, because they are based on the tap changing transformer control variables, and which are based on mechanical switches. Okay. So, TR and TI, so changing this TR or TI are slow controls. So, it is essentially changing the tap position from one step to another step. So, even if you want to change one step of the tap, it takes 5 to 6 seconds per step, because they are mechanical switches, since mechanical switches are involved. So, there are 2 slow variables, and alpha R and gamma I can be rapidly controlled. Alpha R and gamma I can be rapidly controlled. So, here when we talk about controlling alpha R or gamma I, we do not talk about the time required in terms of seconds. It is a fraction of a cycle in fact. So, in a fraction of a cycle. So, cycle means if I take 50 hertz, it is 20 milliseconds. So, for 50 hertz frequency, it is 20 milliseconds. So, it is not of the order of seconds, it is of the order of tens of milliseconds. So, it is much smaller and hence much faster.